The function, a stretch is a transformation that changes the size and shape of the graph. The original and new graph are not congruent. Fun fact, it's the last thing you not learn for the unit, but the last thing you learn for transformations. So what can happen to any graph is I can have a horizontal or vertical translation, I can have a reflection in the x or y, or I can have a vertical and horizontal stretch. That's it. So after today, we're not learning more, you're not adding more. So tomorrow we put them all together. We also start to kind of today. So vertical stretches are in the form y equals a f of x, or 1 over a y equals f of x, and I multiply the a over and put it into this form, right? I always get it into y equals. Where a is a vertical stretch by a factor of a about the x-axis. The hardest part is remembering the wording. It has to be in this wording. Vertical stretch by a factor of whatever the heck a is about the x-axis. The wording can't be different. You can't be like, stretch, axis, factor of 2, or I don't know, you guys write the craziest things. It has to be in that order. Vertical stretch by a factor of a about the x-axis. So if it's sitting in front here, it's multiplying. So is there anything happening to our x currently? No, so our x stays x, and our y gets multiplied by a. So we get ay. That's it. The catch is, if our a is negative, that's a reflection, not a stretch, right? It's only the number that matters for a stretch. So your stretches will never be negative. You'll never have a vertical stretch by -7. You'll have a vertical stretch by a factor of 7 about the x-axis and a reflection in the x-axis. The negative makes a reflection, not a stretch. So if it's negative, you have two things happening. So here, the points on the x-axis are invariant. If you only have a vertical stretch happening, the points on the x-axis are invariant. Because the coordinates on the x-axis are x0, when you apply the mapping to them, x0 becomes xa times 0. It'll still say x0. Because we're just multiplying, right? When you multiply anything to 0, you still get 0 back. This is the other thing. If a has a negative sign in front of it, it's not a stretch. Remember, it's a reflection in the x-axis. That's the key thing. There's two things happening if that a in front is negative. There's a stretch by the number and a reflection. So let's talk about this one here. It says, describe the transformations that occurred if the original graph of y equals f of x was y equals f of x. Y equals -4 f of x, I skipped that, was y equals -x. State the mapping. So what transformations are happening? Now this is the catch. Your transformations have to be in the order cert. Cert. They could be rust if they want to. They could be RST. They could be SRT. But no matter what, the T has to come last. Because your transformations have to be in order of operations. And your reflection and your stretch are both multiplying, so they have to come first. And then your translations are adding and subtracting, so they always have to come last. So when you state your transformations, they have to be in that order. You could get away with RST. I always say cert, I always do stretch, reflect, translate, but if they did reflect, stretch, they're both multiplication, so the order wouldn't matter. You'd still come out with the same thing. Okay? What you cannot start with is translations, no matter what. All right, so what are our transformations? So we have this is, our x is x. Do you see how it's by itself? That's where the horizontal stuff happens. If it's not in there, it's vertical stuff. Okay? It's affecting the y's. So we know we have a vertical stretch. I'm going to start with stretches first. Vertical stretch by a factor of 4, not -4, right? It's by a factor of 4 about the x-axis. The great thing is if it's affecting the y's, it's always about the x-axis. If it's affecting the x, it's about the y-axis. It doesn't change, even for reflections. So this is about the x-axis because it's affecting my y's. So that got me the 4. The negative is not a stretch. What is it? It's a reflection in the x-axis, same axis. So it's a stretch in the x-axis, a reflection in the x-axis. Okay, now we have to do mapping notation. X, y becomes x. X stays the same because nothing happened to it. You see that? Translations, add and subtract. Stretches and reflections multiply. So what am I going to multiply my y by? Negative 4. It's not tricky, it's all it is. Negative 4. That's it. And if there was a plus 3 at the back, then I'd go add 3, because I would go up 3. That's it. It's not trickery. Okay? So here it says, given the graph of y equals f of x, use a table of values to sketch y equals 2x. So let's talk about the mapping here. Xy becomes, did anything happen to my x? No. And my y becomes what? 2y. Okay, apply your 4 points. Get a new graph. So there are 2 invariant points on this one, because there are 2 places where y is equal to 0. And when I multiply it by something, you'll see it. 5, 6, 7, 8, 10. And I would use a ruler if this was a piece of paper, but I can't. And then this is 1, 2, 3, 4. So this graph got taller. Does that make sense if I'm vertically stretching it by 2? Everything's doubling, except for where it's y is equal to 0, right? So it makes sense that it's getting bigger. Okay, domain. There's something called set notation, and then there's something called interval notation, and you need to know both, because they might ask for it in set notation, they might ask for it in interval notation. Set notation is the squiggly bracket one. I'm going to write this as set notation. Everything in the squiggly bracket, set notation means something. So make sure you're paying attention, because it all means something. So, because math can be written in a lot of symbols. So this means the set of. The squiggly bracket means the set of. That's why we have to write a squiggly bracket. A round bracket does not mean the set of. A square bracket does not mean the set of. Squiggly bracket means the set of. What variable is x in this case? X. And y is y. Sometimes y is f of x. Sometimes y is g of x. Sometimes y is h of x. You'd have to use that as your variable. Okay? So we're saying the set of x values such that, that's what the straight up and down line in mathematics means, such that. So it's the set of x, because we're using x as our variable for x domain, such that. Now where do my x's fall between? This is -2 and this is 4. And I have it, and it's connected between them, correct? Is there any x values this way? Is there any x values this way? No. So it's just between those values. We agree? So when it's between those, you put an x in the middle, and you read your inequality sign from the x. Remember, if it's open to the variable, it means greater. If it's close to the variable, it means less. Correct? So I always go left to right. So I have -2 over here, and I have 4 over here, and I need to put some inequality signs in there. So is x greater than or less than -2? It's greater because it's going to the right, correct? So x is greater than, so I open it up to the x, or equal to -2, because it can equal -2 on the graph. Then I read from the x this way. What is it? Is it less than 4 or greater than 4? It's less than, so I close it to it. So do you see that the actual inequality signs are going the exact same direction? So a lot of people think that means they're both less. No, because you're reading from the x. X is greater than or equal to -2, so it's open. X is less than or equal to 4. If you always put low to high, you can just put them in the same direction. And then we're not done. So we have the set of x variables such that -2 is less than or equal to x is less than or equal to 4. And then I have to keep going. I have to tell you what x can be. So if I just had these as dots, if I just had a dot here and a dot here coordinates, and I didn't connect them, x would be an element of integers, right? Because I would only have those dots. So you have to keep going because x could be real numbers, x could be whole numbers, x could be integers. If I want the dots connected, which is what I wanted, right? I want all the dots connected. If I want the dots connected, x has to be an element of the real numbers. That means every decimal is included. So if ever you're taking coordinates and you're connecting them, your variable has to be an element of real numbers, because that's how you get all the decimals in between. Does it make sense while we write it out like that? Every single thing in that set notation means something in mathematics. So if we do range for set notation, we're going to have our variable is y. If it was f of x equals, I would say f of x. If it was g of x equals, I would say g of x, but it says y equals, so I'm going to put a y. Such that, what's my lowest y? 0. What's my highest y? 10. And then in between them, correct? Greater than 0, less than 10. So we're going to go 0, 10, y in between. Y is greater than or equal to 0. Y is less than or equal to 10. And are they connected? Y is an element of the reals. So that's set notation. Once you get calculus, set notation goes out the window. So then we do interval. So interval notation, I think, is the easiest because it's just representing your numbers on a number line. So if I take my x values and put them on a number line, so if I take the x-axis and I put it on a number line, I would have -2, I would have 4, I would have closed dots because they're equal to those values, and I would have in between. Do we agree? Closed dots mean square brackets. So I put square brackets, put -2, I put a 4, I put a comma. That's it. So you're representing a number line. Square brackets for equal to. Can never equal infinity, so if you use that, can't. -2, 4, close brackets. Now if I take the y-axis as a number line, and I write it sideways, I'm going from 0 to 10. Can I equal 0? Yeah, I have 2 dots on it. Can I equal 10? Yeah, I have dots on it, so it's closed dots. And then it's between them. So it's square bracket, 0, comma 10. Just write them in the order of the number line. Okay, this one is y equals x squared. They want to replace y with 3y. So replace means I go to the y just like replacing a tire. I take the tire off, I put on new tire, right? Here I have the equation y equals 3x squared, or sorry, that's a line. Y equals x squared. And they want me to replace y with 3y. So I take y, it's replacement notation. I throw y out and I replace it with 3y. If it makes you feel better, go like this. Put brackets around your x. Because the square is attached to it, correct? Now I always want to get into y equals. How do I get the 3 over? Divide by 3? So now I have y equals x squared divided by 3. We will never write it like this. What's the better way to write it? Instead of 3 underneath, I could write it as what in front? 1/3. Now some people say it's attached to the x. Is it? It's not attached to the x. If it was attached to the y here, when I move it over, it's still going to be with the y, guys. It'll never go from the y and move itself in. Just by moving it over by division. So we'll just talk about the transformations and mapping. We won't draw the graph for now. So what is this? This is a vertical stretch. It's not with the x. Vertical stretch by a factor of what? Of 1/3. About what axis? So if it's affecting the y's, it'll always be about the x-axis. Is there a reflection on this one? No, the 1/3 is positive. And then you're mapping x, y becomes x. Nothing happens to my x and my x stays. And if the stretch, what do I do to the y? Multiply it by 1/3. Remember how horizontal was opposite for x's? Like if it was x plus 4, we went 4 to the left. If it was x minus 4, we went 4 to the right. Horizontal stretches always flip. So the vertical always stays the same. So do you see how it was a 1/3 in front? We multiply by 1/3. Horizontal stretches always flip. So words and mapping are the same thing, correct? So if I have a 2 horizontal stretch by a factor of 2, I'm going to multiply by 2. We agree? Because words and mapping are the same thing. But the equation, they're opposite. So here it says horizontal stretches are in the form y equals b to the x. Now watch this. Horizontal stretch by a factor of 1/b. It's always the reciprocal about the x-axis. So if I have a b beside my x, I'm actually multiplying by 1/b. Always flips. So your mapping notation would be 1/bx, comma y. The points on the y-axis are invariant because now our x is 0 there, y, and when I multiply by 1/b, it still stays as 0. And the same thing, if b is a negative sign, that's not a stretch, that's a reflection in the y-axis. So, is the 5 in this one here, it says describe the transformations that occurred if the original graph of y equals f of 5x was y equals f of x. Then state mapping. So, is this affecting the x or the y? It's affecting the x. Do you agree? So what's my mapping going to be? X, y becomes what? 1/5x, comma y. So whenever you go from across the equal signs, this is what I always say. So if I go equation to words are mapping, the x's flip. So do you see I'm not crossing over for words or mapping? Everyone paying attention because this is where it's going to go downhill. Yes? You can just like poke them. Wake up, Tom. All right. All right. So here we have 1/5 is in my mapping. Do you see that? Yes? So 1/5 is going to be in my words because it doesn't flip. Do you see how they're in the same heart? So I'm going to have horizontal stretch. By a factor of 1/5 about the what axis? About the y-axis. We're going to bypass the next 2 examples and we're going to go right into a whole bunch of equations just to solidify it before we go. So we're going to go to here. So this is my equation, correct? Do we agree? It's still here. So we don't include any of that in transformations because that stayed the same. The only thing that changed is I got a 3 in front. When I have a 3 in front, what is that? It's a vertical stretch. Does the vertical stretch, if you have it in y equals, does the number always just stay what it is? Yes, in equation, in words, in mapping. So when people are flipping the verticals around, I'm like, what are you doing? The vertical never flips, ever. Vertical translations, do what it is. Vertical stretches, always the same, right? So if you're ever taking a vertical and you're like, I wonder if it flips, it never flips. If you get into y equals, your verticals will be what they are. So this one here is a vertical stretch. By a factor of what? 3. About the x-axis. And mapping you do as you say. So it's vertical, nothing happened horizontally, so my x stays the same. And if I had a 3 in the words, I'm going to have a 3 in the mapping, correct? And what do I do with stretches? Multiply. Stretches and reflections multiply. This one, I have 4 minus x cubed. This one, I have 4 minus 2x cubed. The 2 is with the x. We agree? So when it's x's, I use my little equation, 2 words mapping, little diagram. I'm going from equation, this is an equation, we agree? To words and mapping. If I cross the arrow, the number flips. We agree? So going from equation to words and mapping. So what number am I going to use in words and mapping? 2? I'm going to use a half. I'm going to use a half. So whenever I go from equation to words and mapping, or words and mapping to equation, that bad boy flips. But if I'm going from words to mapping, or mapping to words, does the number flip? No, they're in a heart. They're together. They're half. It's only when you cross over the arrow. So I have a horizontal stretch. By a factor of what? One half about the y-axis. I'm going from equation to words. This is an equation. It's going to flip. Now I'm going from words to mapping. So what does that half do? Stays a half. Because if I'm going from words to mapping, which is what I'm doing currently, whatever the heck the number is in words stays the same. So I'm going to get xy becomes 1/2 x comma 1. Only affected by x's. All right, let's try again. This one here says, describe the transformations that occurred in state mapping if the original function was x squared. Now it's going to get complicated. Lots of stuff going on. So this is the x. If people are like, I don't know if the -2 is with the x or not. If the -2 is with the x, it would have to be in brackets, correct? It's not in brackets, so the -2 is not with the x. So what happened to my x here? Absolutely nothing. And if you get it in y equals, your y's are what your y's are. So my vertical stretch is going to use 2. I have a reflection, and I'm going to go 3 up. The y's are the easiest. They don't change. If you get it into y equals, your y's are what your y's are. So I have that -2 in front. That -2 in front is a vertical stretch. Nothing's affecting my x. By a factor of 2. Not -2, that's a reflection. About the x-axis. I have to do stretch, reflect, translate, cert. So next I have to do reflections. Are there a reflection? Yeah, there's a negative. It's with the y, so it's a reflection in the x-axis. And then what's this 3? Vertical translation. Three units up. So my mapping is xy becomes x comma. I know nothing happened to my x because my bracket, my x is nothing happening to it. Remember, stretches and reflections multiply. Translations add or subtract. So I used 2, so I'm going to get negative 2y plus 3. If you have y transformations, you should throw a party. Y transformations are easy. What they are in equation, they are in words, they are in mapping. Nothing changes. You see, it's a 2, it's a 2, it's a 2, it's a negative, plus 3, plus 3. Y's are the best. Y's do not change, no matter where I go. Now B, they'll do this a lot. What was my rule? We'll go to C for a second here. What was my rule about horizontal translations? They're always the what? Opposite. But I didn't actually explain it this well. What's in front of my x every single time we've been doing horizontal translation so far? The 1. Do we agree? Even in grade 11 it was a 1 because we didn't talk about horizontal stretches in grade 11. We didn't talk about reflections in the y-axis in grade 11. We just had horizontal translation. So there was always a 1 in front of that x. You didn't realize it, but there always was. So we'll talk about this one right now because it has a 1 in front. This affects my x, correct? So it's going to be a horizontal translation. Two units, and then people sometimes get stuck. Remember this. I'm going from equation to words. We agree? And for x's, when I go from equation to words, it flips. Correct? So if this is x minus 2, it's 2 units what? Right. Vertical. What does vertical always do? Stays the same. Vertical is your best friend. Vertical does not change. You throw a party whenever anything is vertical. So vertical translation, 1 unit what? Up. Now I'm going to go from words to mapping. If I'm going from words to mapping is in a heart. Do you agree? Words and mapping are always the same. What number you use in words, you use in mapping, right? So here I would have x, y becomes, I'm going to read my words. Horizontal translation, 2 units right. How do I move right? X plus 2 I add. And then vertical translation, 1 unit up. I'm going to go y plus 1. What's the catch with B? What's in front of the x? A 1? What's in front of it? A negative 2. If you don't have a 1 in front of your x, your horizontal translation is going to be wrong every time. So they'll do this as an extra step. So we actually have to get into y equals, and we have to get a 1 in front of our x before we start doing anything. Do we have a 1 currently? No. So I'm going to go open bracket, and I'm going to GCF the negative 2 out of these two terms, so I get a 1. So if I take a negative 2 out of negative 2x, taking out of GCF or greatest common factor, the mathematics you do is division, right? So negative 2 divided by negative 2 is 1x. This is looking good. And then 4 divided by negative 2 is negative 2 squared. Now will my horizontal translation be correct? Yes, because what do I have in front of the x? A 1. I have to have a 1 in front of my x or my horizontal translation will be wrong every time. So let's talk about this. I'm going from equation two words with x values. So what's going to happen to my numbers? They're all going to flip. Do you agree? The only thing that doesn't is a negative sign because it's just a reflection. But here we have a horizontal stretch. By a factor of what? 1/2. Do you think they'll have the one with the 2 as well? Yep. So this is what I'm saying. If you only know 80%, it's scary. If you don't know when to flip or not to flip, they'll have both options. About the y-axis. The negative is not a stretch. The negative is a reflection in the y-axis. And a horizontal translation to units what? Right. And then mapping and words are in a heart, so they're going to be the same. So x, y becomes negative, what number am I going to use? Negative 1/2, because what words have a half? Mapping has a half. Yes, words and mapping have same numbers. So words has a half, mapping has a half. Because words and mapping mean the same thing. X, and then I need to move 2 right. Do you see example 6? Do you see example 7? Do you see example 8? Try them. We're going to go through them tomorrow. I'm not going to give you any homework right now because it's still fresh, but just try them. 6, 7, 8. You got like 4 minutes. Even if you get done 6, just keep trying them. Try till the best. 6, 7, 8. Go.